What? Okay, so we finished off to the middle of page 2. So we finished off all of page 2. The example for you starts on the top of next page. Okay, Mr. Up, fix your notes. Okay, so a weight hanging from the spring is stretched 5 centimeters beyond its rest position rest position s equals 0, and released at time t equals 0 to bob up and down. Its position at any later time t is s equals 5 cos t. So, just a nice application of cosine and sine graphs. What is its velocity at any time t? So, its position is 5 cos t. Its velocity, v, is equal to v of t. That's bad. S of t. V of t is equal to s prime of t. So, Mr. App, copy the 5 down. Put your thumb over it. What's the derivative of cos t? Negative sine t. Okay. So we clean that up. Negative 5 sine t. So that's our velocity. Our acceleration, a of t, is s double prime of t, or v prime of t. So, Mr. What you're saying is copy the negative 5 down, put your thumb over it. What's the derivative of sine t? Just cos t. Mr. Rep, the jerk, j of t, is s triple prime of t, which is v double prime of t, which is equal to, copy the negative 5 down, put your thumb over it. The derivative of cos is, and then if you deal with it a little bit of clean-upage, you get 5 sine t. Okay, so a sudden change in acceleration is called a jerk. Therefore, a jerk is the derivative of acceleration. Its body's position at any time t is the derivative of acceleration. Mr. Ad. Position, velocity, acceleration, jerk. Right? Most of the time, most people don't feel a jerk. Right? When you jerks only happen when you're rapidly accelerating in another direction. So crash into a wall, yeah, your body, you're accelerating in as your body moves into the wall, it's accelerating the other way, or decelerating, and that really hurts. Jerk, most people's bodies feel jerks through whiplash or accidents. That's the jerk. Concussions. Your skull is stopped, but your brain inside the skull is still moving forward. Your skull is now going the other direction, and your brain hits the front of your skull and causes bruising, or the side of your skull causes bruising, and that's all a concussion is. It's a jerk. Your brain doesn't like that. Okay? Okay. Determine the jerk caused by the constant acceleration of gravity. Well, I guess we could start with the position function. S of t equals negative 4.9 t squared. So if I jump out of a relatively decent airplane with no upward or downward velocity, I guess I should plus something. I don't know, 700. I jump out of a plane at 700 meters. That's my height above the ground at any time t. So S prime of t would be negative 9.8 t, and then S double prime of t would be negative 9.8, and then the jerk, S triple prime of t, would be 0. Gravity doesn't cause jerks. Gravity just pulls. Okay? You go, whoa, gravity just gave me a pull, a little tug there. Doesn't happen, folks. Okay? Okay. Derivatives of other basic trig functions. Okay. Tan. What? We've already done it. B. B is up there. How much room do we got? Yeah. Okay, so we're going to do tan and maybe a couple others. So tan, Mr. App, I don't know what tan is, and I'm not going to give you the rule. We're going to get the rule ourselves. So, Mr. App, you could write tan x. How else could you write tan x? Over cos. Yep. So the derivative of tan x is equal to the derivative of sine x over cos x. OMG. What rule are we going to use? Quotient. Quotient. Quotient rule! Top is sine x. Derivative of the top is cos x. The bottom is cos x. The derivative of the bottom is negative sine x. So, use the quotient rule. Derivative of the top, cos x, times the bottom, cos x, minus the derivative of the bottom, times the top. All over the bottom squared. Bottom squared. Cos cos plus sine sine. I know, isn't it a beautiful thing? One over cos squared. The derivative of tan is 1 over cos squared. Mr. App, do you write it as 1 over cos squared? No, 1 over cos squared is for suckers. Secant squared. Okay? Now, you can actually get all the other ones doing this, but I'm going to cheat and flip to the page in your textbook that gives you all the other ones. Because the only one I really remember is the derivative of tan is secant squared. But I know I can get all the other ones by using the quotient rule. Yay! Quotient rule! Nobody sings along with me. What? Yeah, laser sword. Okay, derivative of secant is secant x tan x. The derivative of cotan. Now, okay, start to recognize patterns here. Is negative cosecant squared. The derivative of cosecant is going to be negative cosecant cotan. Make an observation. This is a little trick that a friend of mine uses. No. It's almost like a biology thing. Well, I don't know if I just burned all the biology teachers. But if it starts with a C, it's negative. They're always negative. Well, it comes from the Pythagorean identities. Well, cosecant's 1 over negative. That's negative 1 over sine x. Do you want me to do one of the other ones just to show you how we get them? No? Well, if I ask you to find the derivative of cotan, either you're going to memorize it or you're just going to write cotan as cos over sine and use the quotient rule. Right? What? Yeah, 1 would be the top, and the bottom would be sine, and then you would go after it. Yes, good call. Sorry. I didn't understand what you're saying. Everybody hear what Aaron was saying? If we asked you to do this one of nice spelling, then you would start off with, and you would say the top is 1 and the bottom is sine. Yeah? And then the derivative of the top would be 0, and the derivative of the bottom would be cos. And then you would just drop everything where it needs to be, and you would end up getting negative cosecant squared. Okay? Good? Okay. What? Well, oh, sorry, negative cosecant cotangent. Yeah, sorry. Yeah, sorry, I'm an idiot. Yeah. You follow the instructions, you would get this as an answer. Eventually. Okay, tangent and normal lines. What are the lines that are tangent and normal to the graph of at x equals 2? Okay, so the first thing we need to do is, hey, Mr. App, when x is 2, we need to find y. Y is what? So y equals tan x over x. So what are you going to do? How am I going to find my y coordinate? Okay, type it in your calculator. You're right. Or just leave it like that if you don't want to work it out as a decimal. Who wants to work it out? Who wants to leave it like that? Who doesn't know? Doesn't care actually would be a better statement. Yeah. So you can type that in your calculator and get that as a decimal. Or you can just leave it like that and say, Mr. App, that's a number. Right? It's not a very nice number, but it's still a number. Okay. So we know the top is tan x. Top is tan x. We know the bottom is x. The derivative of the top is secant squared x. The bottom is 1. Quotient rule. Just a second. Quotient rule. Okay, that's better. Secant squared x times x minus 1 times tan x all over x squared. Blick. Okay, find the slope. So m is going to be secant squared 2 times 2 minus tan 2 all over 2 squared. I'm thinking that the issue that you're going to have is not so much getting the derivative. The issue is going to be, please let me be able to type in my calculators properly to get the slope. Yeah? So what I'm going to do is get an answer for the numerator, and then I'm going to divide it by 4. Yeah. 1 divided by cos 2 squared, like that, times 2 times 2 minus tan of 2, enter, divided by 4, enter, 3.43-ish. Yes? Yes? Now, if you're really afraid, and how many of us are okay, we only got one person. I bet you there's more. Thank you for being honest about your fears. Okay. If you're really afraid, don't forget that your calculator can help you. Thank you, calculator. You're my bestest friend in the whole world. Hit the graph button. It's going to look like a pile of garbage because it's just doing funky things. Because we're dividing by 0 in a whole bunch of different places. Look at all those asymptotes. And then hit second trace. Give me the slope at x equals 2. Now, it lets you check, doesn't it? Hello? So if I say do this algebraically, I'm expecting all of this work. Nobody says that you can't check on your calculator and just make sure that you got the right answer. Right? Like, you guys are all smart kids. You should be able to be able and willing to check your answers. Anyways, okay. So your two equations. Your tangent line would be y minus tan 2 over 2. I'm running out of room, running out of room. Running out of room. No, I'm not anymore. Well, what? So there's the tangent line. Minus tan 2 over 2 equals 3.43 x minus 2. And then the normal line, which is perpendicular, y minus tan 2 over 2 equals negative 1 over 3.43 x minus 2. And you're finished. Good? I'm getting strange looks. Is it because my handwriting's brutal? Be nice, Sarah. I know it's brutal. But it's better than it used to be. You can believe what it looks like when I write on the overhead. It's Charlie Brown smudge. That's why I use chalkboards if I have to. I can't use technology. Okay. Find y prime equals, okay, so t is 5, t prime is 0, b equals sine x, b prime equals cos x. So y prime equals derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom square. Whoops. That was dumb. So an answer would be negative 5 cos x over sine squared x. Another answer could be cos over sine is cotan. And 1 over sine is cosecant. So you could do that as well. Did I blow some minds away? Kind of? Okay. Another strategy that you might use is, Mr. App, this scares me. I don't like quotient. I don't like the quotient rule. Makes it cooler when you say it like that. You could just jump down to that. What? No. And then I'm just covering the 5 up with my thumb. And I'm going, what is the derivative of cosecant? That forces me to memorize more. Right? Doing it that way forces you to memorize more. If you do it the way that I did on the left, you only have to remember the derivative of sine is cos, and the derivative of cos is negative sine. So it depends on which way you like to look at the world. Do you like to fill your brain up with trivia, or do you like to only know a little bit and then use all the applications to do things? I'm kind of in the first camp, because the first way makes more sense to me. Faster, but it requires you to memorize more. Know what I mean? What? You like it? Okay. But do you see it's the same thing? It's just which way do you want to look at the world? Okay, y equals secant x. Do we want to flip back? We're going to do this two different ways. So the way that I would do it is certainly not the way that some of you would. The way that I would do it is change secant into 1 over cos. And then I would use the quotient rule. Oh, I'm just getting excited. I apologize for my excitement. Derivative of the top times the bottom times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay. What rule are you going to use now? Now, what you could do is everybody flip back to the previous page. No, wait. It's at the top of your page. Sorry, I apologize. Everybody look at the top of your page. Do you agree that you could have just jumped, if you had memorized the derivative of secant, you could just jump to here? Riley. Why not? Why not? No. Well, if it's just secant, then show your work none. If you can memorize the derivative of secant is secant tan, then the amount of work you show is none. If you don't know, if you can't memorize the derivative of secant is secant tan, then that's what you're going to have to show me. I'm the kid that had to do that because I don't memorize as well as most kids. I don't have the brain for that. I can mathematically figure things out, which I love because physics, that made sense to me. That's why I did really well in physics. But I don't have the brain for memorization, and that's why I never became a doctor and certainly didn't like biology because I'm just not wired to memorize. I'm not. So I instantly didn't like that. So I knew that I always had to start with basic principles. What is the derivative of sine? What is the derivative of cos? As long as I can know those two, I can do everything in this course. Sometimes it takes me a little bit longer to get to the answer, but I have a better feeling for why the answer is sometimes more than other people that memorize. But you know what? We get the answer. Who cares? Okay. Derivative of tan. I would suggest knowing the derivative of tan. It's going to save you time. So to do the y double prime, I need to do the second derivative. I need to use, instead of the quotient rule, we're going to use product rule. Because it says find y double prime. So y double prime, u is 10x. U prime is secant squared x. V is secant x. Now the nice thing is you know what V prime is. From all that work, you know the derivative of secant. It's itself. It's secant tan. It's all this highlighted work allows you to jump from here down to here now because I did all that work to figure that out. If you're not a memorizer, all you got to do is now drop everything where it belongs. The derivative of the first I should zoom back in again. Just got to drop where it goes. Derivative of the first, secant squared x times the second, secant x. Plus the derivative of the second, secant x tan x, times the first. What was the first? Tan x. This cleans up pretty. Secant cubed x plus secant x tan squared x. And if you really want to impress your friends, you take a secant x out. And then I run over to my Math 12 formula sheet. I don't know if the exam will ask you to do this, but secant squared and tan squared. Oh, they're so close. No, it wouldn't. No, you could take this secant squared. It wouldn't help you very much. You could take that secant squared out and put in 1 plus tan squared, but that doesn't make it any prettier. I was like, oh my God, is that going to be something beautiful? It's not. It's not. I guess if you were into kicks and giggles, you could do this.
Michaela Cameron, can you please contact the office? Thank you.
I guess you could do that. One plus tan squared is secant squared. Well, I'm not going to give you bonus marks. I'm just going to suggest that if you stop, I'm just going to suggest that you want to stop here or here. Yeah? Well, it's not going to make you use that identity in that way because it doesn't help you. Like if it was a wow, all of a sudden it becomes 1, like a sine squared plus a cos squared, then yeah, you'd better do that because that's just silly not to. But on a Friday night and on a Saturday morning, yeah, when everybody's looking at you like, what? Okay. Bye, everybody.